Welcome to this explainer. All right, let's just jump right in because we are looking at a massive cosmic mystery today. I want you to imagine the universe, right? Not as some blank, endless, boring void, but actually as a giant musical instrument. Think of a colossal, intricately folded geometric bell playing this cosmic symphony that's been vibrating literally since the dawn of time. I know, it sounds super poetic, but as we'll see today, through a really fascinating framework called mode identity theory, this is actually a rigid mathematical reality. So here's the mystery that's going to hook us. When we listen to the universe's absolute oldest music, the cosmic microwave background, or CMB, which is the literal afterglow of the Big Bang, we find something incredibly strange. The universe is actually missing its lowest frequencies. It's kind of like if you sat down at a grand piano, struck the lowest bass keys with all your might, and heard absolutely nothing. Why in the world is the cosmos so quiet at its grandest scales?
Section 1. The Cosmic Symphony.
To really grasp why this missing sound is such a big deal, we kind of have to look at the history here. For decades, we've been launching our absolute best, most sophisticated instruments into space just to listen to this background radiation. And look, this isn't some new glitch. Way back in 1992, the Kobe satellite first spotted these early anomalies. Then by 2003, WMAP confirmed it. Yep, there's missing large-scale power. And then by 2013, the Planck satellite definitively recorded what physicists call the low L deficit, basically a distinct lack of signal at the broadest measurable spatial scales, or multipoles. So for over 30 years, our best instruments have all agreed the grandest scales of the universe are inexplicably quiet. The contrast between what we expect and what we actually see is just fascinating. Standard cosmology, the Lambda CDM model, which is basically our standard textbook understanding of the universe, expects this beautiful, complete, continuous spectrum of cosmic sound. But when we observe the actual CMB, bam, there's a sudden, steep drop-off in power right below what's called multipole 30. Standard physics predicts those low notes should absolutely be booming, but in reality, they just aren't there.
Section 2. The Shape of Space.
To solve this whole anomaly, mode identity theory asks us to just completely flip our perspective and look at the actual shape of space itself. Like, what if we stop viewing the universe as this featureless blob expanding infinitely and instead treat it as an object with a specific, highly structured geometry? According to the source material, the physical space of our universe has a distinct topological shape. Mathematically, it's defined as S3 over 2i. Basically, in plain English, that means the universe is a three-sphere structured by something called the binary icosahedral group. This creates a highly specific 120-cell discrete domain. Remember that magnificent rigid geometric bell we talked about earlier? The shape is incredibly symmetric, but it is finite and it's highly structured. And this specific geometric shape isn't just some abstract math idea. It naturally predicts the exact 4 anomalies scientists have been scratching their heads over for decades. For instance, that low multiple deficit we just talked about, well, this geometry predicts a transition right around multipole 29. The anomalous quadrupole, essentially the second lowest possible harmonic, it's mathematically filtered out. Parity asymmetry, that comes from a Mobius twist inherently built into this space. And the preferred axis in the CMB, it aligns perfectly with the normal of that exact seam twist. I really want to pause on a profound quote from the research here. You see, certain alignments in the CMB are so unexpectedly weird that cosmologists actually jokingly nicknamed them the axis of evil. But under this geometric framework, these aren't observational errors. They aren't strange cosmic coincidences. They are actual structural clues pointing directly to the physical shape of reality.
Section 3. The Molian Gap.
So this specific geometry builds into something completely mind-bending, the Molian Gap. Because the universe has this precise binary icosahedral geometry, that geometry creates a structural boundary. Think about a physical trumpet, right? A trumpet literally cannot play a note lower than its fundamental frequency because its brass shape physically prevents those sound waves from even existing inside it. Well, the Molian Gap is the universe's version of that brass tubing. It mathematically filters and mutes specific cosmic frequencies. On this 120-cell domain, energy shells n equals 2 all the way through n equals 10 are completely empty. Like, they just don't exist. The very first note the universe is even capable of playing on these large scales is shell n equals 12. And because those lower shells are gone, the quadrupole, which would normally get its power from them, is totally starved of power. The gap boundary at n equals 10 is a hard, rigid geometric limit. The cosmic instrument simply cannot vibrate there.
So the absolutely crucial takeaway here is this.
Pure, abstract geometry is directly dictating the macroscopic reality we observe in the night sky. The universe is acting exactly like a giant acoustic high-pass filter. It's literally erasing the lowest frequencies of creation, which perfectly explains why COBE, WMAP, and Planck all heard complete silence at the largest scales. Section 4. Locking in the radius. All right, this brings us to the final, and honestly, most exciting investigation of this explainer. If we know exactly where the cosmic sound turns off, we can measure the exact size of the instrument itself. We are literally locking in the radius of space from the stars. Let's walk through this incredible logical chain. Step 1. We take the mathematical Molian gap boundary, which we know is n equals 10. Step 2. We map this boundary to what we actually observe in the CMB sky, which is that power drop-off at multiple 29. Step 3. Using the known co-moving distance to the CMB, which is basically the distance light has traveled since the universe became transparent, about 14.0 gigaparsecs, we plug these into the geometric formula. We are reverse engineering the absolute size of the universe from a mathematical shadow cast on the Big Bang's afterglow. And the math returns this exact number, 5.3 gigaparsecs. This is the ultimate cinematic payoff of this entire theory. 5.3 gigaparsecs isn't just some arbitrary estimate. It is the rigidly calculated exact radius of our universe, derived purely from mapping the Molian gap to the CMB anomalies. The contrast in how this changes our fundamental understanding is just massive. In standard cosmology, the radius of the universe, r, is basically an arbitrary unconstrained scale. It just happens to be whatever it is. But in mode identity theory, r is rigidly locked. It absolutely must be exactly 5.3 gigaparsecs, completely dictated by the pure geometry of the space we live in. Our cosmos isn't some boundless, random, inflating balloon. It's a precisely tuned instrument with a fixed size. And as a final validation, if space is indeed this 5.3 gigaparsec geometric bell, we just need to figure out where we're sitting inside it. By calculating our observer position at a specific distance from the domain's center, the predictions align astonishingly well. The gap boundary, the suppressed quadrupole ratio, the specific parity asymmetry of 0.81, and the alignment angle of about 10 degrees. The mathematical predictions from this topology line up almost perfectly with the actual observations measured by our satellites. It is just incredibly satisfying. By simply understanding the fundamental shape and the exact size of this cosmic instrument, a 30-year-old mystery completely vanishes. One geometry, one observer position inside it, 4 massive observational anomalies solved, all at the same time. We've seen how the missing low notes in the sky allowed us to mathematically lock in the exact radius of the universe. And it leaves us with a truly staggering thought. If the abstract shape of the universe directly dictates its exact size in the physical anomalies we see in the stars, well, what else is pure geometry hiding in plain sight? Could the masses of our particles, or even the nature of dark energy, also just be the universe playing chords on this exact same geometric bell? Thanks for joining me on this explainer, and keep looking up.